Now coming to the theophylline and theobromine synthesis process, I already introductory part discussed. Theophylline and theobromine, these are also the methylated benzene, and these are the also synthesized by the method, two method. The first one is the Fischer synthesis, and in that method we taken the uric acid. That one is the uric acid we taken, and it will react with the methyl iodide in the presence of the sodium hydroxide, and it will dimethylated because here two molecules of the methyl iodide used, and it is the dimethylated and the 1 and 3 position. So it will produce the compound which is dimethylated at the 1 and 3 position. So 1,3 dimethyl uric acid. This is the compound. It is a further react with the PuCl3. It is a further react with the PuCl3 to get chlorinated at the position of the 8. So this ketonic group is the chlorinated at the 8 position. So it become this one. That is the easily dechlorinated by using reducing agent, and here is the reduction to give 1,3 dimethyl xanthine, or you can say that is the theophylline. So this one is the method by used. So this synthesis is the known as the Fischer synthesis. In another synthesis we already discussed in the synthesis of the caffeine. This one is the Tarbes synthesis. So here we taken the urea, which is the dimethylated. For the dimethylation of the urea, we can use methylamine. Two molecules of the methylamine we can use. So it is the dimethylated, and it will produce dimethylurea. See, that one is the NaHCH3 and NaHCH2. Okay, and this Na dimethylurea, which is react with the cyanoacetic acid. So 1, 2, 3, 4. This one is the CH2, cyanoacetic acid, to produce a xanthine derivative. What will obtain? That will obtain the pyrimidine ring. Here the reagent used, that is the carry out in the presence of the heat. Here is the heat required. Some amount of the heat required. So it will, this one is the C2H5 ways remove out. This in nitrogen easily react with that carbonyl compound. So here is the ketonic group obtained. This C double bond O, which is the urea, that one is the attached at that position. Now coming that, there is the CH2Cl. Here is the primarily occurs the Cl, which is on a react in the presence of the sodium amide. In the presence of the sodium amide, so this one is the easily form, and this nitrogen is the form NH2. So it will form the 1, 2, 3, 4 amino uracil, and that is the further we treated with the HNO2 or nitrous acid. So here is the 5 position we can obtain that NO, that is the NH2, remaining are same, this is the NCH3. Okay, the NCH2 substitution in the occurs, that is the NCH3 substituted at NCH3 position. So NCH3 NO, this NO is the easily converted to the NH2 by using zinc H2SO4 or zinc water. By using zinc water, this one is the easily converted to the NH2, and what will the structure obtained? N-methyl, NH2, NH2. The next step, in the presence of the formic acid, COOH, in the presence of NOH is the required. So here is the xanthine nucleus obtained. So there is the re-closure reaction is the occurs, and it will finally produce a compound which is that is the NaH double bond O methyl. So on the treatment of the acetic acid, this one is the formic acid. In the it will form the compound which is the final compound, the theophylline. Okay, so in that cases the first intermediate, here is the first intermediate formyl derivative is the occur, and when second it will hydrolysis using zinc water, it will produce the final compound theophylline. So these two are the synthesis method. This one is the Tauber synthesis, and this is the also studied in the caffeine synthesis, that theophylline, when it is subjected for the methylation, it will produce the caffeine. Okay, or theophylline oxidation কি হচ্ছে, oxidation alloxan হচ্ছে, which is dimethylated, one dimethylated alloxan, and it will produce in that is the urea, which is NaCOCH2. So this is the about theobromine and theophylline. So theobromine is also prepared by the same process. Here this is the also Fischer synthesis occurs. The methyl iodide is the used for the treatment of the by ethyl iodide in the presence of the sulfuric, in the presence of the sodium hydroxide, it will produces the 3-methyl uric acid, which is the 3-methylated uric acid, and which is next subjected for the chlorination, and it will produces the 8-chloro 3-methyl uric acid. Let's see the structure of that compound. As that is the uric acid is treated with the methyl iodide in the presence of the sodium hydroxide for the synthesis of the theobromine. What happened? This limited methyl iodide is the used, so that it will only act at the 3 position, so it will produce a 3-methyl uric acid, and 3-methyl uric acid is subjected for chlorination, phosphorylsyl chloride, and it will produces the 8-chloro 3-methyl. And next cases we will again treated with the methyl iodide to that's why that will the easily at the 1 position easily it will methylated by the CH3, and further by the reduction it will produces theobromine. This one is the Fischer synthesis method, and in the Tauber synthesis method, In the Traub synthesis method, the spelling of Traub synthesis Traubes. This one is the Traub synthesis method. The urea is the methylated. Here is the one molecule of the methylene used, so it will produces monomethyl urea. It will produces monomethyl urea, so that it will easily react with the cyanoacetic acid to form the 3-methyl uracil. And this 3-methyl uracil, this one is from 3-methyl uracil, and when heat is required, it will convert it to the NH2. And this one is the at the second position, another amino group inserted by using nitrous oxide and the zinc water, followed zinc water, to there is another NH2 group inserted at the position of that position of the 5. Okay, finally it will react with the formic acid in the presence of the sodium hydroxide and the zinc water. So it will produces not the zinc water, only the formic acid in the presence of the sodium hydroxide. It will produces a compound which is xanthine derivative. See that at the position of the 3 there is a methyl substitution, but at the 7 there is no methyl substitution. So at the last, that is react with the methyl iodide. So methyl substitution occurs at the position of the 7, and it will form the final compound, that is the theobromine. So by this method, one is the Fischer synthesis, another one is the Traub synthesis. We can easily synthesize the methylated xanthine. So the uses of the theobromine and theophylline, that theophylline is the uses as a bronchodilatory activity, CNS stimulant, as well as it is used as the treatment of the neonatal apnea, whereas theobromine is the various uses like that. It is used in the treatment of the asthma, also the used in the having the vasodilator activity. Okay, so that's are the all about the methylated xanthine. In the next class we will discuss about the remaining are, I think, one is the azepines, another is the acridine derivative. Okay, thank you.